special design review meeting is expected to focus on the CMDB engine work. We haven't talked about it for a while, although it's been it's in active development for our team, and we think it's really core, so we wanted to lay out some of the things we're discussing. One of the design premises that I do want to stress is, while we have some very big ideas on what we think this could be and how it should be done, we're working very iteratively in the design. So we want to make sure that we lay in the right underpinnings, we want to test it, we want to make things work, and then we will add complexity as we encounter the issues that we need, not in advance. And this will become really obvious when we talk about search, and so I'll create a sub. We spent a long time on the Dell team talking about search. And what we have done in our development efforts is we've split the CMDB work into two paths. We have an inbound path. Actually, I'm gonna stop for a second and talk about design objectives as a review, and an outbound path. So we have a.
Actually,
go ahead.
Rob, that's actually. Sorry, there was a huge echo and delay. It might make sense to start with what we're trying to achieve.
That's what.
All
right. We are likely the source of the echo. Let me mute and see if tell me if the echo goes away.
That means I need to stop, right?
Yes, that's right.
It's gone. Yep.
Okay, it's entirely us. I know how to fix this. Andy, do you want to give an intro, and we will play that while we're muted?
I don't care who's doing the talk. I just thought that we might want to start with the main things we wanted to fix.
You start. I'm going to fix the audio on our end.
Okay. So I guess there are a couple of things, big annoying things that we're trying to address.
One of you guys take notes, or?
One is, when things fail, it'd be nice to know why, right? If you apply a new proposal on a node that already has multiple proposals applied to it, it's very hard to tell which one failed, because sorry, I was looking down. Because any one of the proceedings, you create a pile, and what's the name? Jenga? Something below you in the pile might have failed. So that's one issue. Another issue is that there's some big dissonance between Chef's attitude to the world and Crowbar. So Crowbar is an orchestration system where we want to take step n+1 after we know that step n worked. Right? So we assume, or we rely on the fact that if we apply a set of roles, actually, to a set of nodes, that the next step will find us and
successfully utilize the roles that were already deployed. Chef is more of a eventual consistency, because it's asynchronous internally in various ways, and the way that the search database is being updated uses a full text search engine that is very slow to update and consumes a lot of data. So on a client side, well, actually any search, but especially on client side search, your results may vary. Right? You assume that if node A successfully applied a set of roles, and node B is searching for all the nodes that have some roles, it will consistently find node A. Well, eventually. So that's driving our desire to avoid search from the client side as much as possible, so we can feel a lot more consistent. And maybe I should have mentioned this the first bullet. We also want to be CMDB abstraction. So Crowbar can operate, the logic in Crowbar, the orchestration engine, the proposal configuration, all those pieces that operate independently of the way that the results are manifested in the node. I'll check out though and see if it makes any sense.
I'm still having audio issues. By the way, we're trying to resolve it in the background. I think Andy, you're doing a good job talking about Chef and our concerns about Chef.
I was more curious if Adam, James, if it's new to you guys, if you've heard it, or if it makes sense. Yeah, Mr. Chief, so now thanks for explaining that. It's not really new. I guess I've read about it in the previous meeting minutes that you guys are working on this. So I think it's great that you're moving to a model that is CMDB agnostic. I'm just curious, what CMDB do we plan to support from Crowbar 2.0? So is it just decoupled from Chef, but still more or less we will use Chef? Or are you guys also actively going to introduce and test with Puppet or some other stuff? Like CF Engine?
Enter your process
Well,
ID
CF
and
Engine,
press the pound key.
Puppet Engine evolved from it. So
we want to make sure that the main solution that we care about work. So our primary target right now is Chef. Sorry, some folks are having issue with the audio. Let me.
Yeah, I cannot get the Skype bridge to work at all, and I can't get the direct IP feed to work at all. I can offer the Dell bridge as a mechanism. Okay, good. I'm set.
So I think we're using the telephone dial-in, and yeah, that works pretty well.
That's the only thing that's working right now. If somebody could post that. Okay. I'm gonna.
Does that work with people with Skype calls this dial-in number?
It will not work. If you dial in from Skype, it will not work. Which is frustrating, but.
I'm dialed into the normal, like, international dial-in number via Skype.
I'm trying the 800, not the US 800 number from Skype, and it's not connect. It's not closing the call. Let me see.
Yeah, usually, for other conference calls, at least for me, if I use Skype to call the US number, sometimes I have to call the non-toll-free one, and that usually works. But I don't know. I haven't tried for this one.
You have it, because I'm looking online and all I see is the 186.
Welcome to the Dell conferencing.
Sorry, I'm adding in the other Dell.
Hash code followed by the hash or pound sign.
I just did it wrong. Sorry, everybody. I'm trying to get the Dell as a backup. I'll post the link in a second.
Okay, so let's put that in the background. So back to the.
Digits have been detected.
So the idea is to create an abstraction layer that can, at least for thought exercises be proven to work with whatever you want to plug in with the appropriate stuff. So for example, part of the design will accommodate having Crowbar be an external classifier for a Puppet master, so we can drive the Puppet decisions for node deployment. That said, how we're going to build it, and when we ship, we're not gating the release on that. Because our primary target is to make sure that we can deploy OpenStack with either our recipes or some variants that we're trying to collaborate on with other whatever OpenStackers. to basically have a set of community maintained recipes.
Mm-hmm. Yeah, I think that makes a lot of sense then.
Andy?
The range echo.
Yeah. Sorry, Chris, are you up? Is that you?
I'm sorry, that was me. Wayne, you're saying that we want the chef recipes, for example, to be independent of Crowbar itself so that they can be developed and independently and sourced from other areas, right?
Again, it's not a primary goal, that's an aspirational goal.
Okay.
So there is, if you look at the big folks out there, if you look at AT&T, Rackspace, Greenhost, Open, Opscode, we all are plagiarizing heavily from each other, but have enough sufficient differences where we can't directly share our cookbook. I think Opscode, Matt Ray has been driving some efforts to stop doing that and let's just come up with a set of cookbooks that are shareable in the different environments and are not different in minute but not interoperable ways.
Gotcha.
So for example, if you look at one of the things we hit early on with Crowbar is using Chef in Crowbar was that Chef has a somewhat simplistic notion of networking. So a node has one IP address, the canonical IP address, and that's it. Well, no. In most of the people, a given node has much more complex networking environment. So when we initially started with Crowbar, then we built the network bar client and we built a much more evolved model around IP address for logical network, mapping to physical networks, and all that business. That model, to a large degree, has been replicated by all the other folks because we all share the same chef deficiency, and Crowbar, whatever, our team came up with a pretty decent solution, and it was tweaked in various ways to map to other folks' solutions. But they diverged. So now the idea is let's see if we can converge back again. Does that make any sense?
Yes.
Okay.
Okay.
So should we start dealing on talking about the details?
Yes. Is our audio sufficient now? Are we?
For me.
Okay, good. I just want to make sure we're not causing more audio problems by talking. So, and I do want to respect that. I apologize for the long startup in audio, but so I do want to try and keep this to the time limit, and if we need to continue on, we will, and we can also continue this on the lists. So this is a complex subject, but we broke the problem and the way we're coding it down into sort of 4 areas that we discussed pretty heavily. One is the inbound path, in which data I'm not going to try and type it. If somebody else wants to try and capture it, I'll tweak it. In which data is coming from the CMDB system. And just to make things simpler, right now we're very focused on Chef because that's where all of our cookbooks are. And where all the deployment code is. We are working very hard to make sure this is abstract, and if somebody wants to work on Puppet in parallel, we would welcome that. But I'm going to use Chef rather than the word CMDB to be more explicit. So what we recognize is that Chef through OHI, and OHI is extensible, is collecting a huge amount of data. Most of that data we don't care about. Some of that data we do care about. And so what we've recognized is that we need, and I'm actually going to be more specific than we, but Crowbar needs that data. So this big blob of JSON data that is being collected from OHI, which is sort of the heart of the Chef infrastructure, comes into Crowbar,
Well, this is the inbound path?
The inbound path. Today, the inbound path, there is none. We just take the OHI data and Chef stores it, and then we go reach into Chef to get it. By moving to a database, we've made that not practical. Actually, by wanting to abstract it, we've made it not practical. And so what we recognize is that this big OHI data has to be stored in Crowbar somehow. And we don't want to store the data itself, because Chef does that. What we want is just to capture the pieces of information that Crowbar needs to know from that data, okay? We're not trying to replicate Chef.
Can I jump in for a second? Because I think you made one leap of faith that
Yeah,
that would hinder understanding. So Crowbar needs to make decisions based on information that is discovered from nodes. In Crowbar 1.0, we reach into Chef. In Crowbar 2.0, to facilitate abstraction, the abstraction of using different CMDBs, we can't assume that the data about the physical node is in a format that comes from Chef. The Puppet might represent similar pieces of data or other pieces of data in slightly different formats.
Chef, right. Puppet has a similar mechanism factor, and it also recognizes that there might be other sources of data that are unrelated to the CMDB system, such as pre-populating it from a factory spreadsheet with a whole bunch of data. We have all these use cases where data needs to flow into Crowbar, and we need to put it in a place where it can be consumed by other things, the API, the UI, other bar clamps. So the purpose of the inbound path is to get important data, not all data, important data, and store it and make it available for Crowbar consumers, okay? And what we recognize is that that data is actually filtered by the bar clamps. And this has been an important design implementation that you'll hopefully see in code, as this is my next task to code, is that what we're expecting to happen is when new data comes into the system, it'll come in through the CMDB system, and there can be multiple instances of the multiple CMDBs, is going to give that data, it comes in by node, it's going to push that data into the bar clamps to make decisions about it. And part of our design pattern is to treat the bar clamps as a little bit as black boxes. They decide what they want to do. So they take this chunk of data from the CMDB system, they look at that data, and they choose what of that data is important for them to publish. So, for example, if you were the networking is a really complex example, but if you're the networking system, you're going to publish things about that node, like the interfaces that it has, the IPs that are on those interfaces, the networks they're attached to, those types of things.
If you publish, you mean outbound?
Well, publish into Crowbar, so make available as attributes into Crowbar, and those. And it's effectively a reflection of the physical system. So if you were the IPMI bar clamp, you would choose to publish the relevant IPMI information. What we recognize in the design is that bar clamps might store information, right, or not. They might publish all the information they have, or they might keep some data internally. The networking bar clamp has a very complex internal representation that it does not need to fully expose. The IPMI bar clamp or the DNS bar clamp, or those are very simple bar clamps. All of their data is probably published and shows up as attributes. So when we get information from the nodes about the world according to Factor or OHI or whatever else, the bar clamps are going to get a bite at that apple, and they're going to take the things that they think are useful and publish them as attributes. That's the inbound path. The thing that's important is the inbound path includes the bar clamps. So when you publish a new bar clamp, you're going to have the choice of which data you want to publish, right? Which data you're effectively exposing, and also from which sources. So we don't expect every bar clamp to respond to every type of data. You might have a bar clamp that's not Puppet enabled that doesn't understand factor input. That's okay. It would be up to the community adding Puppet support to add the ability to understand a factor input as opposed to a OHI input. So that's the inbound path is to collect that data. I'll pause for a second. I know that's a huge lump. It's taken us hours of discussion to sort of coalesce it to this. Good.
So let me ask, so our source of data about the nodes themselves comes, at least in this instantiation, from OHI and is made available through Chef from OHI.
Uh-huh.
And the bar clamps might consume some of that data and themselves publish
Node what we're calling right now node attributes. Right.
So they synthesize some of that information and publish their own additional data.
They publish the data that the system thinks is important. Now, developing bar clamps is a very circular path. So it could be that I'm working on a bar clamp for DNS and I need some network information. And I have two choices at that point. I can either grab it from the node when bar clamps publish it, or I can make changes to the network bar clamp to then expose information that I need. And we will wind that path as we go, right? And we've talked about, but haven't implemented the idea of being able to request different bar clamps, implement different attributes. And there's all sorts of complexities that we're not adding right now. One of the things to understand with this is that this has been implemented, it's already in code, as the node attribute pairing. So you create an attribute's a single thing, right? There's a design question that we haven't implemented, which is what's the namespace for attributes? Right now, there is only one namespace for attributes and you can't have collisions. And every attribute is managed by a bar clamp. These are reflected in the data models. But when a node data comes in through the CMDB system, the bar clamp is going to take that data, take the things it wants, and push values, create a link between the node and the attribute that hold the value that it's publishing. I'm so deep in the code. I'm pausing because I want to make sure it's clear, because I know how I'm implementing it, and translating is hard. There's a point in here that Judd's not there to speak up about. Somebody might ask, very reasonably, how the data gets in from Chef to Crowbar, and Judd's been working on reporting, on using the report mechanism. Puppet has a very similar mechanism to this, but so we actually will get effectively an event notification when a Chef runs, a CMDB runs, and that run information is actually the triggering event for putting in this data, and we track the runs, and we're going to tie it back to a run. So every time there's a run, we'll get an event notification, and that is what's going to trigger this data coming in through the system. If you watch Judd's check-ins, Judd's been working on the reporting piece for how we bring Chef data in.
The Chef terminology is the report handler and exception handler.
Right.
Basically, it's the conclusion of the Chef execution on the client. On each client, it produces this very detailed report, including resources that were modified and known attribute values and so on. And the plan is to capture that.
And the Puppet has a similar thing. We used to use it before we switched to Chef. It's like an injection. I'd have to go back a ways and look it up. But this is a nice thing about this is a very supported mechanism. It's very repeatable and scalable. All right, so in the interest of time, I'm going to move from the inbound path to outbound path. And Andy, if it's all right, I'll set it up a little bit, but I'm going to turn it over to you to talk about what the design elements are for outbound. Once again, this is a reflection of a lot more discussion than we were going to have time for. But the idea with the outbound path is that we are going to, when a proposal, also called a configuration, we're still transitioning those names. When those changes are made, we need to be able to tell Chef that here is information that you need to run, and you need to run this cookbook, and that's done. It's done through roles. There's a whole bunch of activity that has to happen. The thing I want to set up is that there's attributes. Key thing to understand: there's attributes here for both for nodes and for the bar clamps themselves, where we have to inject information and get it to flow through the system. That's a key path. What we spent a lot of time discussing, and I'm assuming Andy's going to break this into two pieces, is that you also have this complexity of bar clamps depending on other bar clamps, or cookbooks depending on other cookbooks.
And that controls, the dependency controls what?
The dependency is actually the thing that's interesting. The dependency controls when how the Nova controller finds Keystone and finds Glance and finds the Cinder and all these. So the interdependency of these attributes is actually how all of the orchestration fits itself together. Okay, and that's why closing the loop is really very complex. Andy, the reason I started is because I know that you'll have a clarification, and I think hearing two people explain it might be helpful. Go ahead.
Okay. So maybe to set the stage the way slightly different, not slightly different, but a little different.
Good.
If we start from the use cases, there are basically two main use cases for attributes. One is for attributes on the outbound path. One is for bar clamps to coordinate between different nodes within the bar clamp. Right? So, for example, if you look at Swift, which is my favorite example, when you try to compute the Swift ring file, which basically needs to list the IP address and disks and ports across the cluster, Swift needs to be able to go and find already deployed and had their disks discovered and formatted and whatever not and made available, and fetch all that information and create a ring file out of it. Right, so this is intra-bar clamp collaboration, but across different nodes. Nowadays, it's basically performed using search, which we talked about with greatness. In the core, basically both examples are things we do with search now. In the bar clamp collaboration, there's lots of examples. For example, nobody needs to find the MySQL database and derive a connection string out of it. Another kind of really interesting use case that we don't currently support, but we spent some time on, is let's assume that we deploy API endpoints in high availability fashion and put load balancer in front of them. Right, so we take Keystone, we have two Keystone API endpoints, and they have their own internal IP address, or whatever internal IP address they're listening on. And we then deploy a load balancer bar clamp that deploys two instances of your favorite load balancing technology that exposes a virtual IP address that all the consumers of Keystone should be using to benefit from the high availability. So, assuming that things get installed and configured, the interesting point in the context of outbound attributes is how is a consumer of Keystone to learn about the right virtual IP address to be used. And what if it actually also cares about learning of the individual IP addresses of the Keystone API endpoint? Are those use cases same? Do people nod approvingly?
Wouldn't the client just talk to Keystone and Keystone would be coordinating that?
Well, not quite, because any one Keystone instance doesn't necessarily know about the other. If you truly want them to be highly available, you want to deploy them in kind of a share nothing, or as close as you can to it. So each Keystone instance knows about itself, it's not necessarily about its buddies.
That make sense? Yep.
And today we use search to make it where the data is just out there and you get it. And there's some concerns about search because of the eventual consistency, and there's a lot of assumptions about where things are and having to find them. And so it's not authoritative. So what Andy's describing here is the ability to say to the Nova bar clamp or the Swift bar clamp, here is the information you need to set up your cluster. Give it all to that bar clamp, not have it go asking other bar clamps what it is inside of Chef or inside of Puppet. Now, inside of Crowbar, where all those things are authoritative attributes, then that's where the appropriate part is to sort of pull all those things together. And we know dependencies between bar clamps, and we have a lot of information for building good attributes to inject.
So, to say what Rob said slightly differently.
No, good. Well, Andy, this is a really complex subject. I want us to be restating pieces so that...
No, I understood. That's partly why I'm doing everything.
Good.
So if we take the Swift example, in multiple cases, I've seen failures on large clusters where the search hasn't completed updating its indexes. So Chef Solar is still churning on things. And the first time we build the rings, not all nodes are included. In a large cluster, that kind of flies because we can add nodes later. In a small cluster, if you end up not finding, for example, any nodes, then you end up failing to build the cluster because you can't build a zero-node storage cluster. Services won't run. So this eventual consistency versus authoritative information causes failures when search fails. Rob, you also touched on what we internally call attribute-driven recipes,
Right.
which is effectively I'm doing search, providing information rather than search for it on the client side. Right, so the intention is that the bar clamp can query authoritative sources, create a picture of the world as it should be, and then pass that information to the CMDB layer that will map it into the appropriate structures for, well, Chef. So based on the database querying of where are all the storage nodes and what disks do they have, information that comes from the inbound attribute from a previous Chef run. The CMDB layer will the Swift bar clamp will provide the CMDB layer with all the information that needs to be pushed into a role on Chef that describes configuration to apply when the next Chef run runs.
Right. And just as a note, we're not trying to eliminate search. We think that there's issues with it, but we're going to migrate towards the attribute-driven cookbooks as quickly as we can. But
So we had a very politically correct way of saying avoid but not disallow or such. Try to avoid it but not tell you you can't use it. Yeah, I think that
or
was
don't block,
a better way.
right?
What is searching for what? These are chef searches.
So Chef has no concept of a central database or even relationships between bar clamps. So what it does is inside of a cookbook, when you need an attribute, if you don't have it, what you do is you can then go looking for it throughout the whole system. So you can say, oh, I need to know all of the Swift storage nodes, and I need to know what their disks are. So what you do is you say, hey, tell me all the nodes that are Swift storage nodes, and then you go looking inside of each one of those for the Swift data that you want to take, that you need to use to do your computation.
Okay.
And so what we're saying is, instead of searching for that, we're saying Crowbar is the authoritative source for all the nodes. And so when you go build the Swift ring, we expect the bar clamp to collect the information that is needed by the recipes, rather than have the recipe search for it. So if you look through our current cookbooks, you'll find a lot of places where we search for information.
But the recipes will address the bar clamp instead of doing the chef search?
So this is actually what Andy's about to get to, which is how they find the information that they need to take out. No, this is exactly the question's exactly right. It's the segue. Today you can look through our bar clamps and find a whole bunch of places where we search for information. Our goal is to take all of those search locations, which are brittle and rely on a whole bunch of assumptions and things like that, and then turn them into injections, where we give the information to the cookbook and then say, go do this work. And the subtlety here is that because we're an orchestration system, we don't expect to give it to just fire and forget. What we're planning to do is you give the bar clamp and the cookbook enough information to go do its next step, and then you give it more information, or you get. So the idea is information is passed to Chef that's appropriate for Chef to take the actions that you want it to take. It's an important point from an orchestration perspective, and it's one of the reasons search doesn't work well for us, because search lets you always get all the information, and if you're changing the system around, that search result is not reliable. Right. That's
one thing to emphasize, that one of the things we spend time on is to make sure. So one of the goals of this whole exercise is to be able to also collaborate on cookbooks directly without having compatible cookbooks both with Crowbar and other systems. So one of the things we spend time on is to make sure that the way we push information into Chef could actually be achieved from the cookbook perspective in an environment that is not Crowbar. So, for example, one of the things that some of our cookbooks do now is have so a set of values that Chef will inject on nodes to which this cookbook is deployed, that allow the recipe to execute as if Crowbar provided those values, but without Crowbar. Right, so
what Andy's describing is community upstream cookbooks. So by injecting the attributes, the cookbook doesn't really care how they got there. So we could take our cookbooks and share them with anybody, right? Attribute driven is actually is emerging as a best practice. So our cookbooks could be used without Crowbar. All somebody has to do is put the data in the right place, and we could use community cookbooks that expect attributes to come in, and then so we could take advantage of the Cassandra cookbooks that are in the community by just injecting attributes into the places where the Cassandra bar clamps expect to find them.
Injecting by what machinery?
Andy?
So in the Crowbar case, that's actually my last latest pull request was basically allowing Crowbar to be able to point to a Chef server and talk to it. So Chef actually has a RESTful API that's exposed in Chef object where we can actually go and create a data bag or create a role or twiddle this and twiddle that. And that Crowbar 1.0 actually already does that. It's just less flexible. Let's assume that it talks to one Chef server that's installed on the admin, and there's all kinds of authentication and authorization issues there. So in a Crowbar environment, we basically would, the CMDB layer, so the CMDB layer has a couple of abstractions. There is the CMDB abstraction, that exposes an API to the rest of Crowbar that basically deals with, hey, I want to apply a proposal, and based on the proposal and the bar client defined set of state, go and schedule running this role on these sets of nodes, and that completes these other roles on these other sets of nodes, and so on. So the same machinery that exists in Crowbar 1.0 is actually a previous pull request started moving that to be stored in the database and managed as an abstract CMDB event and CMDB run. So CMDB event is apply proposal, and a CMDB run object represents a single execution of a Chef client on a particular node. So those are tracked in the database, so we can, do all kinds of fun stuff with that. That's the Crowbar facing layer. The CMDB facing layer basically is responsible for taking the abstract constructs and converting them into structures in the underlying CMDB. So for Chef, that means that when you want to apply a proposal, you will go and update the node roles in Chef or the affected nodes to add elements into their run list, to inject as node of role attributes actually the configuration for the proposal. Those are the main two things. And then effectively go and trigger Chef execution on all the affected nodes. So in a Crowbar environment, that CMDB Chef object is basically the one that's pushing stuff into Chef. Outside of a Crowbar environment, you basically could use the standard Chef tools to, for example, you can have default attributes in a cookbook, or you can go modify roles and add your own attributes similar to our config roles. You can go and create a role that represents a deployed cluster and put all the information in there. I think, for example, for Swift, there are a couple of cookbooks out there. So some folks were not very comfortable around automatically computing ring files because they felt they need manual control of exactly identifying what goes where. So rather than using search, there are some cookbooks out there that basically stick everything into a data bag, fully describing the Swift cluster, and then have the recipe read the data bag and drive its operation from there. Did that answer the question? Or did that make sense?
Mostly.
So just as a time check, we're just about out of time. I know based on our own internal conversations about these topics that we haven't spent enough time on it. And part of what we've been trying to do is show in code a lot of these what we're doing in the simplest forms, and then knowing will add complexity.
So Rob, maybe we spend the next couple of minutes seeing what doesn't make sense, or if we missed some use cases, or.
So let's do this. I agree with you. I think what we should do is not try to discuss them, but capture them, if that's all right, and have people say, all right, I don't understand this. We need more information, and we'll capture topics. Does that sound? Because what I don't want to do is I don't want to spend another 30 minutes right now on back and forth discussion. I'd like to know what we need to focus on in a future meeting. But I think we've gotten enough that people can look at pull requests if they want. They can engage online, and we can have chats about it and stuff like that. That's right. Our goal here is to set up those conversations.
So this is Alan. From my perspective, it would be really useful to continue this discussion with a UML class diagram in front of us. I've seen the class diagram floating around before, but I've never talked through that with anybody or heard anyone talking about it, and I don't know whether it's being updated as things change. But there's been kind of small mentions of the various some of the classes in the discussion just now, and it would be good to see them mapped out visually and talk through the relationships between them. I think that would be a helpful way, at least for me, of continuing the discussion.
I think that would be great. So actually, I would even prefer a step back. So having some kind of a use case diagram. So like if I'm a user and trying to use Crowbar for the first time, what problem is it trying to solve, and how is this different from the current Crowbar? So I'm sort of asking this in anticipation that we will have a designer jumping in from the user side. So his name is Ken, and he probably will join the planning call next week. So he will look at the UI, and I think what designers are, they're going to start asking a lot of questions about how it's going to be used. He has been working on the cloud for a while, so he knows some of the technical pieces behind it, but of course it's not from a pure technical background. So he will ask a lot of pretty basic, like from a user point of view, questions.
Good.
So I don't know if you guys have the time for that, but if you have something we could discuss about it, if there's documents, that'll be even better. That'll be really nice to help him get up to speed, and then he can talk about some proposals he has to change the UI and to make the UI nicer and so on. So
let's add that as a topic in itself. And I'm happy to have more interactive sessions that we can then ping on, because I feel like we have a catch up in design time. I think a use case meeting would be very helpful. Before we started, I don't think they're useful anymore. We had a ton of use cases we wrote down. I don't know if they're worth bringing back or not. They might be, because they're probably still useful. So I think UI improvements is I'm going to add it to this list up here instead of down there, because it's really its own topic, not just CMDB related.
Okay.
We'd love to. Okay, I'm going to just copy this up, Adam. Because when we track this list, this will help us know if we need more of the interactive design sessions. And we are looking at FOSDEM, by the way. I don't. We have to decide pretty soon, obviously. But okay, we got past that. We're here. Okay. What other things about the CMDB specifically do we want? Do you have questions on, or do we need more drilling on? I can tell you one of the things we talk about. Go ahead.
Go ahead.
I'd be interested in hearing a bit about the kind of reliability and recovery aspects of it. So if the Crowbar app or the machine that it's on catastrophically dies mid-run, application of a configuration, You know, how does it recover from that after, that kind of thing.
I like it.
So at a very short answer, it's all in the database. As opposed to in Crowbar 1, a lot of it was memory only.
Right, but then you still have to kind of look at the database on recovery and figure out, you know, what the remediation steps are.
Yeah. And the other aspect of moving a lot of stuff into the database was that it's shareable by multiple admin nodes. So you could have a backup admin node that you can bring up.
Yeah.
I'm adding that to the pending topics list.
Is there really a concept of transactions? So, like, if I want to bring up some service, I may need, like, 5 things to be done at once. And if not all 5 are there, then it doesn't make sense. Is there some, something provision for this, or
Yes.
plan for that?
So way back when we found one of the motivations for the CMDB work is to make failures more clear and recovery from failures. But yes and no. I'll leave it for the future discussion because the full discussion is longer.
And this is back and forth because there's forwards and backwards dependencies, and transactions are effectively part of that mechanism. Okay. Good questions. All right, cool. We're a little bit over, but I think this is a good start. We'll keep coming back to it. Don't be hesitant if you think of topics we want to cover to add it to the pending topics list, and we'll go from there. We should probably make sure we flow things off of the list and into this, off of the group discussion lists and into this page. And I finally had the idea that I could be posting these markdown documents into the GitHub as a historical record instead of going off of the speaker list. So I'm going to look into doing that because I have all the historical join me sessions, and once the pages are done, we can GitHub them. So.
Yeah, that would be great. It would also be kind of useful. You shouldn't lose much sleep over it, but it'd just be nice if we standardised on a date format for these. Sometimes we're using little endian dates, sometimes big endian, and different things.
So
it's just sometimes a bit hard to.
I totally agree. My thought had been for 2013 to standardize on this format because I think it's unambiguous. It's sprint, day, month as a word, and then year, 2-digit year. Is that reasonable, or is there a different format you prefer?
I have a mild preference for big endian, just because when you're typing in the URL, it kind of gives you the completions in a more useful.
Oh, that's a good point. I am very receptive to that. It's a reasonable. It's a very reasonable change. Okay.
Sorry, what is big endian for dates mean?
Oh, so year first.
Right. So this sprint would be including the 20 or not?
I prefer that because it's just less ambiguous. It's slightly easier to read.
Like that? Do you include the month, or do you like as text, or would you see it like this?
I don't mind. Maybe better because then that eliminates any ambiguity between. And I know Americans sometimes like to have the date and the month the other way around from what Europeans are used to.
Right. But that's why I thought to put in spelled out.
Yeah, that's cool.
But if we're doing big endian, it becomes clear.
Yeah, that reversal really applies to little Indian dates.
Yeah, Americans are pretty consistent. If they see the year first, they know the month is next. So.
Okay, well, in that case, there is a small advantage in if this is ever going to affect, file listings, then you can just sort and then get it all sorted if it's numerical.
Yeah, that's the other thing.
I don't know whether that applies here.
Yeah, that's the other reason that I like big endian with numerical is that it pretty much automatically, pretty much just a straight, alphanumeric sort will always get the ordering correct.
That's true. You want dashes or not? I actually think.
Yes, please.
Yeah, you need some sort of separator in there.
Got it. Good. Thank you, Adam, for bringing that up. I can't change the URLs for to sync in that easily, but when I migrate them over, I can do that pretty easily. Cool. All right, everybody, have a great day. Next meeting is Thursday. Next official meeting is Thursday morning. With this design backlog, do we want to try and do another Wednesday review Wednesday at 10 review session?
Yeah, sounds good to me.
Okay, I'll update the calendar and we'll get that going. And Adam, you want to do the OBS diagram at that point, and then we can see about. Actually, why don't we? You want to focus on the use case design, the use case stuff at that point?
I don't mind.
Okay. So let's do that. All right. I will put it on the calendar. Thank you, everyone.
Thanks.
Thank you.